for another day. So you're going to be so good at this. But we're going to use it for another situation that may arise. So it says find the distance, what they call C, between 3, 0 and 7, negative 5 on the coordinate plane, round to the nearest tenth. So to find the distance between the 2 points, it says step number 1, plot the points 3, 0 and 7, negative 5 on the coordinate plane and connect them with a segment. Now remember, your ordered pairs are x, y, x, y. So somebody give me directions. If I started at 0, 0, how do I get to 3, 0? Tell me directions left, right, up, down. Davion?
So you start, and you go right 3 times.
Okay, do I need to go up or down? No?
No, you don't go up or down.
Why not?
Because there's no like line.
Yeah, I'm sorry. I got distracted by the gigantic chomping that was happening behind me. I thought he busted a tooth in the process of eating that Jolly Rancher. Okay, take your hood off. 3, 0 is correct. All right, somebody else help me go 7, negative 5. Right 7. Very good. Now it says connect them with a segment. So I draw a line. Terrible line, clearly. And I'm going to call it C because that's what they called it in the problem. This segment will be the hypotenuse of the right triangle. Draw 2 other segments to form the right triangle. If I want to find the length of this, I can't just count diagonally because you don't know the distance across that. It's not 1 when you go diagonally across there. So if I drop the first point that Davion gave me all the way straight down and then connect it to what Will gave me, do you see your right triangle? I could put the 90-degree mark here. And everybody says, Miss Hoff, you can't put the 90 degrees there. Yesterday we said we couldn't. But I know with the grid lines, it's perfectly vertical and perfectly horizontal. So if I have a right triangle, if I knew how tall and how wide my triangle was, I could figure out my hypotenuse. Agreed? How could I ever figure out how tall this is? Count. How tall is it?
1, 2, 3, 4, 5.
I would say 5. How wide is it? 4. So now I have a right triangle with a side of 5 and a side of 4, and I need to find the hypotenuse. This is going back to what we did on Tuesday, agreed? So we're going to use a squared plus b squared equals c squared. What do you want to use for a? 5 squared plus 4 squared. Now, I think there should be another step in here. I don't like how they have this. 5 squared is 25. 4 squared is 16. When I add those together, I get 41. Then we take the square root of 41. Everybody, nobody shout the answer. Everybody do it on their calculator so you get practice of that. The square root of 41, I want you to round to the nearest tenth. What'd you get, Brant? Anybody else get 6.4? Yeah? Nicely done. So today when we plot those points, we have a segment that's going to be diagonal. And so if we create a right triangle, we can use the Pythagorean theorem, which truthfully is not hard, just a little time consuming, agreed? Just more lead than anything. So let's try this one. Let's find the distance, they call it C, between 3, negative 4 and 1, 2 on the coordinate plane, round to the nearest tenth. First, plot those points and connect them with the dot. One of these times your tooth is just going to fly out or crack. He probably would eat it. He'd probably still chomp on it. You don't know the difference between the Jolly Rancher and his tooth. Yep. You're supposed to plot those 2 points and connect them with the dot. So your side length, C. If I want to make a right triangle, how could I connect these to make a right triangle? This seems like a really silly question, but don't make it too hard. I'm asking a very simple thing. How could I make a right triangle out of what I have here? Down. Very good. Big brain. We have 90 degrees here, yes? What else do I need to know now? Or what is my next thing that I need to figure out? Very good. Count how many boxes tall, how many boxes wide. What you get? 4 wide and 6 tall. Okay? A squared plus B squared equals C squared. If you remember it, I'm good with it. What's your A? 6 squared plus 4 squared equals C squared. On your own, figure this out. Round it to the nearest tenth. Six squared is 36. 4 squared is 16. When I add them together, I get 52. When I take the square root, I get 7 point, I believe it's 2. No worries. No worries. Questions so far?
Oh, wait. No, it's not. What is the, it says leg or paint?
5 and 4. 5 and 4. All right, let's read this guy. Everybody always panics. There's a 1, 2, 3. The map shows 2 walking trails in a park. Both paths end at the picnic area located at C, which is 6, 1. Trail A starts at A, which is -6, 6, and trail B starts at B, which is -10, -11. If each unit on the map represents 0.5 miles, how many miles longer is trail B than trail A? So what they're doing at this 1, 2, 3 is just to break down the question. So the first thing they ask us is, okay, instead of having to reread that thing, or if somebody said, summarize what they're asking you to do. What is this problem asking you to do? Say it again. Do you know which trail is longer? Which one? Trail B. So you're really trying to figure out how much longer it is, right? How much longer is B than A? So I'm trying to figure out how much longer trail B is than trail A. So what's my strategy? How am I going to figure this out? What do I have to know to be able to answer this question? What about the legs? Okay, and you're going to have to put legs on both of those, right, to create a right triangle. Why would you want to have those leg measurements? What's the purpose of them? I think you're onto what I'm looking for. But why does he want to draw and make these right triangles and find the legs? What is his goal? Find the distance of the hypotenuse, right? Find the length of the hypotenuse. So if we find the length of the trails, yes? We need to find the length of both trails. And I think it's absolutely correct. The first thing we got to do is we might as well make these right triangles. We're talking about 2 different things here, okay? So trail A, we need to make this a right triangle. I'm going to drop down this point and then slide this guy over, yes? Question. Carefully before you shout, look at that graph really close. How long are those legs? 2.5. We can have a half? Boom. Okay, so it looks like a half, but technically they go by 2s, right? So really it's 1, yeah. So really you have a 1 right there because it's a half, right? And then how many do you have here? 2 and 2. So you have 2, 2, and 1, which would give you 5. Everybody follow what we just did there? Every grid line is 2. See your graph goes by 2s. So right away, Will said to me, well, it's 1, 2.5, Miss Hoff. But then we realize these are 2s. So really when you go down one grid line, you've gone down 2. 2, 4, but then a half would just be 1, 5 on this. So how far across, or how far is the other leg on that one?
11.
Okay, start at -6.
Wait, doesn't it say each unit on the map represents 0.5?
Miles. We're going to change it to miles later. Right now, we just want to talk about units. That's important, though. Don't forget that, okay? So start at -6. Okay, right here is how far? 2, 4, 6, 8, 10. Why is it a half? Why is it a half? Okay, but we're looking at this bottom line. You're looking at the bottom line. Don't look at the hypotenuse. All you're doing is counting from this all the way to this. We actually had this discussion earlier today in another class too. They said, Ms. Hoff, it doesn't use that whole square. And I know that. Ignore the hypotenuse right now. I just want to know how far from left to right is it. It does go all the way over. Okay, so 12. So then if we go to our trail B, drop it straight down and across. On your own, carefully count how many those are. Don't say it out loud yet. How tall is that triangle? 12. And how wide is it left to right? 16. Okay, we're going to split this up so you don't have to do all of the work. Okay? I'm going to go right here. Will, and Alexis, and all of you guys use trail A and the numbers we found on trail A to figure out how long that trail is. Brant, Spencer, McKinley, and everybody over here, you guys figure out how long trail B is and we'll share information with each other. Nope. A squared plus B squared equals C squared. You guys do trail A, they'll do trail B, and we'll share information. What'd you guys get for trail A? 13, I like it. Trail B? 20, I like that. Now, Davion pointed something out. Up here in our directions, it says, if each unit on the map represents 0.5 miles. So what we just calculated is 13 units on the map. So we have to change units into miles. So we need to take each of these numbers times 0.5. So trail A is 6.5 miles, and trail B is 10 miles. Did I answer their question? What was their question again? Okay, so how do I figure out how much longer it is? Good. 10 minus 6.5 is 3.5 miles. It is 3.5 miles longer. So nothing really tricky today, just making sure you can draw right triangles. So here's my one curveball. Very last problem on the bottom. Quick glance. What's different about this problem than all the other ones we've done? There's no graph. So my question is, what if I asked you to find the distance between 2 points, but I didn't give you a graph? Everybody always says it. Draw one. I don't know about you guys, but my drawing of one is horrendous. It's horrendous. So let's go back here once. In reality, like on the front side, we graphed this, and then we needed to find how far wide it was. Okay, it's 4 wide. Well, how far is it on the x-axis from -3 to +1? 4. And it's 6 tall. So how far is it from -4 to 2 on the y-axis? 6. So really, we're just looking for the difference in our x's and the difference in our y's. Agreed? And in math, difference means what operation? Subtract. Subtract. Okay, so let's go to that last problem. Find the distance between A, which is -2, 1, and B, which is 4, 3, and round to the nearest 10th. We're going to deal with the Pythagorean theorem, so we know we're going to have A, B, and C. And we're going to find C, which is the hypotenuse. For A, let's use the difference or subtraction of our x coordinates. So I would write -2 minus 4. -6. But really, when we're talking distance, can you have a negative distance? So really, there's just 6. If we were going to graph that, there would be 6 between the x's. Now, carefully think before you shout. I want to find the difference in my y's. What is my difference going to look like? 1 minus 3, which is -2. But we can't really have a -2 difference, or distance. It would really be a 2. So then we set this up. A squared plus B squared equals C squared. 6 squared plus 2 squared equals C squared. 6 squared, 36. 2 squared, 4. 36 plus 4, 40. Then what do I need to do? Take the square root, round to the nearest 10th. 6.3. Did you say 0.3? Yes. Now, on your calculator on the computer, the minus sign is the same as the negative sign. There's not 2 separate buttons. Like on your calculators, a lot of times there's 2 separate buttons. I want you to see if you guys can do this. What if I told you one of the points was -2, 7, and the other point was -9, -4? How would my x's set up? Bingo. Everybody type that in on your calculator. I know you probably can do it in your head. -2 minus a -9. What do you get? 7. What do your y's look like then? Do you see why it's minus a negative? You're always going to subtract, and then this number is actually negative, so it ends up minus a negative. Okay? 7 minus a -4 is actually 11. Now, I'm not going to make you do the Pythagorean theorem on that, but just so you really, really pay close attention to your negatives. Remember way back at the beginning of the school year when I would give you the Google form so you could check your answers as you go? I actually made a Google form for this worksheet again. So it is on my lesson plans. If you go to my lesson plans, week 22, Thursday, January 20th, has a link that says check answers here. And you can put in one, you can do the whole worksheet before you check it. It does not matter to me. Okay? Questions at all before I turn you loose? Lesson plans? Week 22, Thursday, January 20th. You bet. Separate question or something to do with this? Okay, give me 1 second. I'll help you. Let me get you your guys' worksheets.